and some other systems that you guys might run into in the field. But I think our presentation is going to be mainly centered around compressors and vacuum pumps. If you guys run into positive displacement pumps, we might be able to touch on that. But yeah.
To do all that. Hey, one thing I like to do at all my presentations is to get a quick 1-minute survey, maybe not even a minute, but who you are, maybe what your job function is, how long you've been with McDonald Miller or in this field, and maybe how long you've been working on compressors, and what is the one burning question you want to know at the end of these 8 hours? Did they tell you this goes to midnight? Oh, okay. Because Sean sent me an agenda. Would you cover this? And it's basically 3 days of work on it there. So we're trying to condense 3 days down to 3 hours. What is that one question that you've got to know? By the time you do it, because I've got an idea what I think you should know, but maybe you need to know something else. So I'm going to start. Okay, guys, in the back. Nobody sat in front. They always get it. So way in the corner there. Yeah. Give me that 1 minute.
Steve Adams, Mac Miller, 15 years, service foreman, North End.
Okay.
Just looking, I guess, for proper maintenance.
Okay, so somebody's going to write that down, either Sam or Ryan. I can do it. Yeah, on the board here. Proper maintenance.
Yeah.
Of what?
Yes. Air compressors and vacuum pumps.
Okay, all right, and I'll come back to a little bit more, yes.
Matt Humphrey, service North End, 11 years.
Okay,
And
so you guys have already topped out Portland, right? Two people over 10 years, they've already topped out all of Portland, right? Yeah, okay, I can rag on Portland since I'm up here, right? Okay, we don't have a football team, we don't have a baseball team. You don't have a basketball team.
We don't really have a baseball team.
Oh. Okay. At any rate, right.
Ryan McCallum, South End, service tech, 10 years.
23 years.
Pretty much same thing, proper maintenance on.
Proper maintenance, okay. We'll put a check by it, but no more, so there's gotta be something else. So by the time you get up here, you're gonna be asking, why is it blue? Okay, so.
Rennie Santiago, 17 years, service tech. How about what not to do?
How about what not to do? Okay, good, good. What not to do? Great.
Glenn Venera, South End foreman, 29 years.
Okay, wow. Anything you gotta know? Like how long a job should take so you can call bullshit on these guys? Okay. Actually, that is a problem. You know, you really have to go out and do some of the work every so often. When I was a manager, I would go out and pull sewage pumps just so the guys wouldn't tell me it's an all-day job. Do that. Sorry.
Jeff Bangale, South Sound Operations Manager.
Okay.
I like to know a little bit about the vac systems, the electronics to connect to it, and how to interface programs.
Okay. That's about a $2,000 class that we give in Portland. I'm sorry. On some of the electronics and other stuff that we do. By the way, we do have real formal classes where you get to actually work on stuff and learn it and do all that, and we spend a week. We have one going on in Portland right now on Cavelco, and I think next week, actually it's sold out, and so is the one in September. It's in Trey at our other plant. You actually go to our factories where they put them together. Sean, I can skip, and how about in the corner?
Who's Sean?
Seth.
Sean. Say.
Hello, Dave.
Dave. Sometimes it's Sean, normally it's Seth.
Sorry, that's right, it's Seth. Steve. Steve. Okay, sorry.
It's Steve. It's Steve, yeah.
All right, how about in the corner? Travis?
Yeah, Travis, I'm a service foreman, I've been here 19 years.
Wow, okay.
I'd like to,
Excellent.
if you could explain in detail how a diffusion pump works.
The fusion pump works. Yeah, that I used to do 20 years ago, but
Is it compressed air?
yes. Vacuum pumps are a compressor, just with another name so we can charge more. Basically, a compressor is something that takes it from one pressure and moves it to a higher pressure. just so we can just get that out of the way. So whether you're coming from a vacuum and you're going to atmospheric, that's a vacuum pump, but in my mind, it's still a compressor. Diffusion pumps basically have a mouth that opens up and waits for a molecule to wander in. And then it closes every so often, and once in a while there's a molecule of air and it pumps it out. When you start getting down to sub-torr kind of ranges for electronics. How about here?
I'm Jake Langston. I'm actually an account manager here with McDonald Miller.
Okay.
I've been here for about 2 months. I've
Okay.
been in the industry for about 2 months, so that's why.
Cool, cool. So you can see what they're actually doing, huh?
Yep.
All right, and what are the capabilities? So what do you want to know? Like
Everything.
what
Whatever you can tell
what
me.
is a compressor?
Yep.
Yeah, okay. Compressor takes something from one pressure and pushes it to a higher pressure in a gaseous form.
Clock's over.
That's what I want.
Class is over, there we go. Did everybody get the test? Did you get to work on the test ahead of time? Go ahead.
My name's Anthony, I'm with Mac Miller for years, service on the east side, I have
Oh.
8 years experience, and I'm just here to listen to smart people's questions.
Smart people's question, okay. That is one of the goals in your career, is to figure out where information is, because we can't know everything anymore. It's almost impossible. Alex?
Alex Stralvo, South Sound service technician, been with Mac Miller for 4 years,
Okay,
in the industry for 9. What I wanna know is just stuff to, like, I guess the main troubleshooting kind of stuff, and like when you're on a service call, what's the first things to kind of
look at, okay. Common calls, I have a section on that we get, to do that. So, good. Zach, I can actually read now that you're closer, guys.
Zach Ardonia, I've been with Mac Miller for 3 weeks.
Whoa,
I'm a driver, and I'm hoping to absorb anything.
okay, so that you can move up, right? That's how we get in our company, a lot of people start in shipping or materials, and then they move up to parts, and then they go service administrator, and then they realize if you want overtime, you better be in the field. So if you got any at least capabilities of working with your hands and using wrenches, and you sort of like that stuff, then there's probably a good shot for you, because we are short of service techs everywhere in our industry. Everywhere in our economy, we're short of service techs. So you don't have a name.
No, I don't.
Uh-oh.
Brendan Thorstad, North Sound Service Tech. I've been with Don Miller for 7 months now.
Okay.
Just basic troubleshooting and maybe more in-depth things. If you guys want to go from the basics to the more in-depth.
Well, yeah, if you can see the handouts here, we're gonna be tough to get into more in depth, but we'll be glad to sacrifice certain things to get to others. So,
Okay.
at any rate, Matthew, right? That's about as far as I can read on my middle.
Yep.
Yeah.
Matthew White, service downtown for 18 years.
Okay.
And I'm looking to see what's new in the art of removing moisture out of tanks and lines before they're dry.
Oh, Seth told me about that might come up, so I got a whole section in it. So, do you like math? You got a calculator?
I do, I have a phone.
Okay, good, because we've got some calculations to go on a little bit here. Let's see. Oleg, okay.
Zone 1 for Seattle. I'm gonna be with Mac Miller here coming up 11 years.
Okay, cool.
I'm just service technician.
Okay.
And
Not just a service technician.
duh.
The service technician. So it sounds like you get all the hard calls, right? No, you know everything. Is this the guy he's supposed to call you, right? All right, good. What do you want to know? Or do you have any compressors that you have to?
I actually looked at one, just a regular pneumatic compressor today.
Okay, pneumatic. It was powered by air?
No, it was feeding a pneumatic system.
Okay.
Really old building, so.
Okay. Oh, a pneumatic HVAC control system. Okay. Yeah, we don't see too many of those around anymore.
They're still out there.
They are.
Okay. Still out there.
Yeah.
I got 3 in it.
I'm Joe Brethauer. I've been with Mac Miller for 6 months, Zone 1, service and maintenance, and really just basic maintenance.
Basic maintenance, okay, all right. Shane?
Shane Weaver, Zone 1, service 2 years, just over 2 years. I was kind of in the same boat, the troubleshooting and what telltale signs.
Okay, and, okay, good.
Bolsonaro service downtown.
You're covering your,
Yeah.
I couldn't pronounce
Fonzie.
it.
Yeah.
Fonzie?
Yep.
Okay,
5 years. And yeah, just like I said, I got like a couple of accounts that have pneumatic, and I know they have compressors on it, so.
okay.
Check them.
So when the compressors go down, do the buildings get really hot or really cold?
Depends on how they set it up.
Set it up, or do they just stay where they were?
They're supposed to
Depends if
go to
they're
heating.
reverse vacuum.
Yeah, reverse or,
Oh, okay, so,
Typically default and heat.
yeah.
okay.
Brian, Southtown Service Technician. I've been with Mac Miller about a year, he was about 10. What else am I supposed to do?
What am I supposed to do?
That's it? I don't know, maybe some rules of thumb for troubleshooting or something like that.
Rules
Like
of thumb,
Like if I
okay.
show up in the middle of the night, things not working, and I'm not calling anybody, what are the first 10 things to check or whatever?
Okay, and that'll be different for different types of compressors, but,
Put down Sam's phone number.
okay.
Already got it saved.
Yeah, okay. Ah,
Harry, Zone 2 and 5 driver, and been with us for about 4 months now. And I don't really have any other questions rather than what's already listed.
okay, good. And Eric?
Yeah, Eric, Southtown, I've been with Mac Miller a little over a year. And, I'm basically just trying to gain general knowledge of how compressors work and troubleshooting and stuff like that.
Excellent.
All of that.
Good.
Mark is on, for, Zone 2, been to Zone 1.
Wow.
Say, 8 years prior to that, we took the family.
Okay. So you've worked on compressors, you probably built some.
Oh, I don't build them, but I work on them.
Okay. Well, good. Our goal, when this was put to us, was to give you enough knowledge of how the systems work so that you know when you're over your head and you should call us, meaning Rodgers, And this sounds a little weird, but, we sort of do the same things you do, but not the whole building. We don't do, I don't know how many systems you guys, we only work on pumps, vacuum pumps, and compressors. And so, of course, we would love that business. But on the other hand, you're there every day. And so you need to know what it is. And every so often, you're going to run into things, should I really tackle that? Or should I call in Rodgers? And I think Alex mentioned it, so, when do you call us? When do you have somebody else come in to do it? I know what it was, what not to do. One of the things you don't want to do is call out an air end on a rotary screw compressor, call it out and say that it needs to be replaced because it's a destructive teardown when we get it back. And so and they go out about once every 10 years. Let's just say 10 years on average for rotary screws. The actual bearings are failing inside the heart of the unit. You don't want to be on the hook for that and call it out, because you might do it once in your career. Our guys, like Sam, what do? About once a week you get sent out on a noisy compressor, to...
Depends, once a week, once a month.
Yeah, call them out, to do that. So, at any rate, so here's what I thought after we did our Portland one and we swapped it a little bit. Here's what we thought. What is a typical installation? And then break into that installation and look at types of compressors. And then there's, once we make, who asked the dryer question? Over here, Matthew, yeah. Then we get into what the aftercooler does and the condensate drains, where they're getting out some of the water. Receivers also get rid of water and store air. Then we go into the filter or the pre-filter for the dryer. You guys should have probably refrigerated and maybe dual tower dryers in your spot. And then out there are point of use filters that are out trying to pick up dirt and other items or scale, just before it goes into a pneumatic tool or into something. And then vacuum. I hope we have time down here. I only have about 6 slides. There are so many things going on in vacuum. For every 100 compressor guys, there's about 2 vacuum guys. Vacuum is another art, you might say. So So what does an installation look like?
Who are you? Filming or do you?
Who am I?
A little bit about yourself.
I'm Jeff Yarnell. I work for Rodgers. This is my 40th year. Right now I head up our audit division, and if we get to it, I have a slide that shows me in there. I do audits on compressed air system for people like Seattle City Light, Bonneville, Cowlitz PUD, the Energy Trust, and Pacific Gas and Electric, and down there. And I try to get customers money to upgrade their system and for efficiency to do that. So that's what I do. And I teach. I like to talk. Just ask my wife. She won't ride with me much any further than the store. So this might be a typical air system. I've got 2 air compressors, and the dashed lines would represent a box around them. These are rotary screw air compressors. They're air cooled with a radiator. They could be water cooled. They could be piston machines. They could be anything. Now this particular diagram shows them going through the dryer first. We're going to show you other installations where we have another receiver right there, what we call a wet receiver. That's a refrigerated dryer on the end there. I don't know if this will work. Right there. And then from there, that's a moisture separator, the yellow, into a receiver, and then into a loop out in there where people are using it. And this is a pretty old school use in a factory or a plant. And we've got, I don't know if he's making a hot water heater, and he's probably doing a refrigerator or something. I don't know. So they're using the air, whether it's individuals or whether it's automated machinery or something like that. So, okay. This is probably what we would see for a typical system with an oil-free rotary screw. Right here, this picture actually shows a VFD on here into a wet or a control receiver. And then from there, through what's called a dual tower dryer. Does anybody have dryers like that that have sort of 2 vertical tanks? And then 5 minutes later, they switch back and forth. Okay. There's usually filters, a pre-filter and after filters into a dry receiver. The air is dry here. There's no moisture in it. You should never see anything draining out of it. Hopefully. Hopefully. And then this goes on out. This might be a hospital package. You might see this in a hospital. They may have hospitals. Okay. This also could be a refrigerated dryer. And we'll talk about the differences. A refrigerator dryer just sounds like it sounds. It just simply gets cold. It pulls the moisture out, just like you would in any system. Okay, so let's look at, here's a drawing. Some people like drawings. Here's a refrigerated dryer, compressor going in. One thing that's considered a best practice is to come in low on a receiver and come out high. This guy, in addition to the moisture separator here coming out of being spit out here, this acts like a moisture separator too. The air has to decelerate, make a turn, and re-accelerate, and so moisture ends up there and will come down and we have an auto drain. Pre-filter, refrigerated dryer, and a dry receiver. Now here we show it coming in high and going out low, and I don't know why they're doing that. There shouldn't be any moisture there. But that's what we show there. Okay. Here's another one with a dual tower system. Different air dryer type. But I've got a pre-filter, and this is to keep any oil from hitting these beds. Anybody changed out these beds yet? Mm-hmm. Yeah, they have. They're full of desiccant, activated alumina. Be sure to wear gloves when you're doing it. Probably breathing masks. That desiccant is like cement. When you put your hand in it, it'll just suck all the moisture right out of it, and it's just uncomfortable for a day or so. Don't eat it, and you can just throw it in the trash. But as long as you don't eat it, you're okay. It's a little bit of an irritant because if you suck it, if you inhale it, it just wants to dry out your lungs a little bit, that kind of stuff. So if you're just handling it and shipping or something like that, and there's a little bit on the bag, that's fine. But if you've got plumes of dust coming out of there, you probably ought to have a respirator, just at least a cover. you know, up there, a dust collector. So, okay. So types of air compressors. Wow. There's positive displacement and there's dynamic. And then once you get to each of these, they split up more and more. And we're going to talk about primarily two items. Right here, if you want to circle that, single acting reciprocating compressors. This is what you're going to find in most buildings for like pneumatic controls, basically up to about 10 horsepower. That's, or let me take it this way, 10 horsepower and down, that's about all you see now. 10 horsepower and down. We're going to go over here to rotaries, helical screw. These are basically 15 horsepower up to about 500 horsepower. And then these guys we're not going to talk about, but I can show you some stuff. Oh, I forgot to bring those in. When we go to the first break, I'll bring in my show and tell toys. The centrifugals pretty much own the market, 500 horse and up. And I mean, there's a few screws above 500. There's some centrifugals below 500. But centrifugals and helical screw are basically the two guys that fight it out for plant air compressors. These are the big guys that run the Boeing factories, the U.S. Gypsum. What's the glass place called now?
Saint-Gobain and
Yeah.
Ardon.
Yeah, it's something different. We have some big units there to do that. But we're going to try and concentrate on these two right here, which are the two you're going to probably run into. These are real cool. These are old school, the big thumpers. Shoom, shoom, shoom. Go back and forth. I think I may even have a picture just to, well, I've got, you can read this too. Positive displacement. That term means that I trap something and then I squeeze it. And it has to get volume change. And so the pressure has to go up. Did I just give you horror of high school physics or high school chemistry? You know, all the gas laws, and they talk about Charles and Boyles and who's that other guy, Dalton? You know, and then yeah, all that. You remember all that stuff, or you're having a nightmare already, a flashback? Positive displacement are the most common items out there. The helical rotary screw represents about 80-85% of the U.S. market for plant air compressors. Centrifugals represent about 15% of the market by numbers. And then below that is this 10 horse, you know, stuff that you see in small body shops. It's what I have in my house. It's probably what you have in your house. Even as small as one that's not much bigger than a 2-pack of cigarette that I carry on my motorcycle. It's a little tiny positive displacement compressor to pump up a tire in 10 minutes when I'm up in the Arctic if I get a problem. So, reciprocating screw, and also roots blowers. If you probably don't run any blowers, but that's for low pressure, maybe 10 pounds. We suck air in and blow it out, and it's a positive displacement. Dynamic is what we use impellers for, and these things are spinning very fast. The impeller I'm going to bring in and show you, it is about 4 inches in diameter, and 500 horsepower goes through that. It's the third stage. I've got a first stage. I don't have the middle stage, but in the third stage, 2,500 cubic feet a minute, but it's moving at about 30,000 RPM. You know, these are big machines that put out a lot of air. You won't come by these, most likely, but they're sort of cool. They're cool because they're big iron. Centrifugals. Sometimes you get into some turbines, but so here's the guy that you're going to see most of the time. Single acting. Single acting means that it's compressing on the top of this piston only. The bottom end is open. There's just 2 one-way valves, and it just goes up and down on a motor, or it's just belt-driven usually. Just belt-driven. So, how many have seen something like this out in there? Okay. Okay, good. Good. They might look like this. You know, on a tank with a mag starter, a 10 horse, only because they put a 10 on there. and it's a Quincy unit, and here's the pump, and I know that it's two-stage. Meaning it comes in one piston, goes over to the next piston, and then goes on up. Goes on up. So there's another one. I mentioned that you won't see many of them above 10 horse, even though this is a 25 horse unit. Probably 1 out of 100 gets sold like this. They almost always go to rotary screws now. The rotary screw people have pushed the market way down from what they supply. That's a 5120. By the way, these are the air filters. That came up in Monday's class. These are the unloading heads right here. There is an air filter, or excuse me, an oil filter right on the end of this. And it has pressure lubrication. It has an actual oil pump on it there, so. Okay. Double acting, I just threw this in just so you could contrast it. You are, when the cylinder is going, or the crankshaft is going this way, connecting rod's going down, we're compressing on this side and we're sucking on this side. It's compressing on both directions of the piston. Yeah, a lot more complicated, very efficient, very efficient. Whoops, and they might look like this, 900 horsepower. 2 stages, there's actually one on this side and one on the other. This is the intercooler to cool the air between them. This motor is a synchronous motor rather than an induction motor, and it's only moving at 200 RPM. But it's 900 horsepower, it stands that tall, and you can stick your hands right into the windings and lose your hand. They put a sort of a guard around it, but that's about it. That's about it. So, we have not built anything better than this in our industry, anything more efficient than this. Yet, you can't buy one unless you buy it used. Find one and rebuild it. Find an old mine or something like that. Primarily because it has unbalanced forces. The foundation costs as much as the machine. You got to dig down about 8 feet. You got to go out about 8 feet beyond it and pour literally a couple hundred yards of concrete in there. They don't come assembled. You got to sort of build them on site. They're so big and so heavy. You literally have to have a machinist stationed there. He's got extra valves. He's always working on it. He's replacing valves and doing all kinds of stuff. He does rig jobs on it once a year, Thanksgiving for the shutdown. So the skill set to work on this, is a true machinist, somebody that builds things. So now let's get into the rotary screw units that might look like this if it's one of the Quincy Northwest or Rodgers units. It's got a motor. This is that air end. This is the piece you don't call out, the one that's actually doing it, and it's just a couple screws turning. Where the yellow fellow I just showed you had probably 300 moving parts and wearing, this one has, 6 bearings and 2 rotors. There's only like 3 moving items in it. And they're continuous running. They run, they love it when you just turn them on and leave them on. We have units out there since the 60s that are still going, that people keep just rebuilding them about every 10 years. And, oh yeah, that's all better, thank you. Seth did that, that's right, Seth. Okay. Dave. Yeah, Dave. I'm sure that's a Jimmy Fallon thing, right? He must do that. Who's Jimmy Fallon, right? You guys, okay. They got a radiator on them, a control panel, and an oil tank, and we inject oil right into the chamber. These 2 screws are, let me pretend I'm the motor over here, and this guy is connected to the motor, and this one just follows along. We suck air in the top, and we inject oil. It's actually on the backside, but right there on that port. And the air and the oil are mixed, and the air is compressed from there to there, and it's all done. And they last forever. Not forever, but they last a long time. And we have some belt drive, some smaller ones are belt drive, or they're in a little cabinet, but our flagship items are open like this so you can work on them. They're in a linear layout so that you can get all the way around it and look at it and work on it. We have over 15,000 of these in the Pacific Northwest. So you'll run across these quite a bit. The really, really old ones, like pre-85, are tan. And then in 86, we switched to blue. I don't know. Are we gonna change, Ryan? We're not gonna change colors anymore. I like the blue, but.
The old ones also had a T-tank separator tank.
Oh, yeah, yeah, Sam, you still work on those.
Oh, yeah. They hold a lot of oil.
They hold a lot of oil. Good point. That's actually a GOAT 1 panel. We haven't even built that panel. I need a new picture. So this is just describing what I was trying to imitate with my fingers there. This is the inlet valve coming here. This disc pulls back and lets the air onto these two rotors. We're driven right here. And off we go. The nice thing is, especially on the smaller ones, they are D or C flanged. So you can, no coupling alignment. That's probably the most technical thing we have to do mechanically, is on some of the big older machines. These are they're just two freestanding items, and you gotta line up the coupling. I probably wouldn't try that yourself. If you're gonna have to change out an air end, you wanna call us, because then the warranty's on us. Does that make sense? And you'll get vibration and stuff like that. You'll wanna call us, have it come in. We can bill you and you can bill them, it doesn't matter, it's not to us.
Yeah, the warranty is affected.
Yeah, whether we install it or not.
Right.
Yeah, what is it? It's 1 year if we install it? A rebuilt unit, yeah.
It's more than that if we install it, but it's 1 year if the customer installs it.
I always thought it was 3 months. We did, man.
Maybe it is.
Yeah, it's been so long since I've been on the commercial side, so.
We've never really had a customer install it, so.
Yeah.
we'll get into
Above
it.
my take rate.
Yeah. So let me go back here. This radiator has two sections, one to cool the oil and one to cool the compressed air. And that's what happens here in this aftercooler. So this is sort of the subset of that agenda. Now we're into how do we treat the air? Because once it gets compressed and leaves the screws, the rest of this is all about treatment and having it the right way. The first thing is the aftercooler, and then all the way down to the dryers, and we're gonna talk about temperatures and pressures and all that.
Hey Jeff, are you gonna go through modulation, like capacity control of the screws?
I can. I've got controls sort of toward the end instead of up front this time. You might look hot club back there if you want to look through look through one of those. I was putting this together yesterday. No, not yesterday. I was in the field yesterday morning. Yeah, and I think I've got that. If not, I got the other one there. Pull it up. Yeah, how do we control these in the set points is another thing I'd like you to be able to know if you're out of whack. So receivers can be large. Yeah, I found that up outside of Missoula, Montana, just parked. The guy didn't have a right permit to haul that. Even though he's in Montana, they don't care about much, but he didn't have a permit to haul that thing. And it's actually one of those trailers, I think, where you ride here. Yeah, there's a guy riding here. This is the back end. This was an old propane tank, about 20,000 gallons. And old propane tanks are great for air receivers because they were rated for 250 pounds. They're extra thick. And with propane in them, they don't have any oxygen at all in there, so they don't rust. The insides are great. So we'll find 20-year-old propane tanks from the Midwest primarily, and haul them out to jobs where we need a tank that big. But most tanks are like this. That's 120-gallon vertical, more like what you might see. Either the compressor's mounted on it or it's right next to it. So we have receivers, and all they are is steel shells. They have a tag on them, ASME tag on there, and the Washington boiler inspector or air receiver inspector, I think you have to have a permit, don't you? Usually somewhere there's something hanging on the wall, right? This is brand new, just came out of our paint shop. I can tell because it's on the funnel there. By the way, when you stop and ask questions, I have candy. Okay, just wanted you to know. Huh?
You're bribing.
No, to throw. Yeah. So just to give you an idea, receiver, and when you send hot air into it, it also acts as a little bit of a radiator around here, you know, and it will hopefully drop out some of the moisture. And it makes it easier for the compressor to control. But like, here's one that just happened to be behind it. That's one mounted on a tank. But let's look at compressed air, and I'll just go over this a little bit. Grains per cubic foot. Oh, it didn't show up. 7,000 grains of water is 1 pound of water, or basically a pint. But this is per cubic foot. So, you know, the air that you and I are breathing right now only has 4 grains in it, if it's saturated. If it's 70%, maybe it's only got 3. I think the example I'm going to go over, it's at 70 and has about 5.6. So just know you can reference back to that. By the way, this is what a refrigerated dryer will do. It'll bring you down to here, about 2.5. A dual tower dryer pulls out even more moisture. The dew point becomes -40. Okay, for extra credit, who can tell me what dew point is?
The temperature where the air is saturated and.
Yeah, condensation is impending, right? Ow! Oh. Yeah, yeah, dew point. Yeah, it also means the relative humidity is at what? You might have got it. I thought I heard it. Who said it?
100%.
100%. Who said that? Right here. There we go. Boy. All right, guys. That's the south side, right? Oh, wait a minute. You guys actually are all the north side guys, right? Aren't you guys?
We're south.
You're on the wrong side of the room, right? All right. So you can see we went from roughly 2.5 to 1/20th of a grain per cubic foot. Now there's a lot of cubic feet after a while, and that's how we get up to the 7,000. But so let's take this real quick. If it was 70 degrees, does it ever get to 70 in Seattle? I was thinking Portland. July. And it's still relatively wet, 70% relative humidity, which means that that air that you and I are breathing is holding 70% of its maximum to get up there. And the atmospheric dew point, that means when I cool it, cubic foot stays the same and it starts to cool as if it's going up and over Mount Rainier. As it cools down at about 60 degrees, it can't hold anymore. And so it starts to rain. And that's why it rains on the upslope of mountains like the Olympic Peninsula or the Cascades. But now let's take this atmospheric air, roughly 8 cubic feet, and compress it to 1 cubic foot. If we assume adiabatic compression, it goes up to almost 500 degrees. Adiabatic just means no heat transfer, and that doesn't happen. You'd have to have the cylinder completely insulated and move it really quick. Most of the time, recips come out at about 250. They come out about 250 because we're trying to, it's radiating from the heads and from the little coils that you see between the stages. Oil-free screws, it is about 400. It is happening real quick, and there's no fluids inside the chamber to take away the heat of compression. Oil-flooded screws are really low because we inject that oil. That oil is going in at 140, and everything comes out, should come out about 180, and it might be as high as 230. When we're all done, going up to here, to this 400, and it could go to 480, when we get it compressed 8 times, the dew point is 130. The pressure dew point is about 130. That means no moisture will show up until it gets down to 130. It should start to sound like your refrigeration systems, right? Dew point and saturation temperatures, okay. So this air that comes out of the compressor is actually very, very dry, even though I've crammed 8 times. By the way, 8 times is roughly 100 pounds. Going from 0 up to 100, we had to compress it about 8 times. So we took 8 cubic feet and we squeezed them into 1. We squeezed them down into 1. Okay. It's very dry because it's hot. But every compressor doesn't like sending out hot air because even though it's, quote, dry, what happens as soon as I send 488 degree air into a plant? Which way does the temperature start to go? Well, the pipe is up, but the air, everything starts to cool down because it's only 60 or 50 in Seattle or 70, right? So it starts to cool down, and when it gets to 130, it starts to rain inside of the pipes. It starts to rain at 130. So what we like to do is cool the air and get rid of the moisture before we send it out of the room. And the easiest way to do that is with a aftercooler. Because we've got 70 degree air, we can blow it across a radiator, or maybe we have 70 degree cooling water. Let's see if I've got it here. So this is at the edge of the end of the screws. It could be as high as 488. If it's a rotary screw, this is only about 200. But it's still dry. We run it through the aftercooler. This red square now turns blue, and we take a lot of liquid condensate out, and we send it on to the plant, or to the air compressor, to the first receiver, hopefully, to the first receiver. Now this is saturated because it's below 130. Saturated. Okay. So you should see this. All this occurs right on the air compressor. We're doing the cheapest thing first. We're rejecting heat to either the cooling water or to the cooling air. Or the receiver is just radiating. So we're getting moisture there. And it's going to look like this. Sorry, Sean, I had to put a couple. I took most of them out. So here's a moisture separator. Here is a drain. I'd forgotten to remove some. I had some repetitive slides that showed up like 3 times in the last one. I moved them up front and I forgot to delete them. So this is taking moisture out in that 90 degrees. After that, you use 70 degree air, run it across the radiator. This is about 90. It's picking up moisture, or it's condensing moisture, and it's pulling out here. So you'll see this. Do you guys ever see dripping right off the compressor or out a drain going like that? You should almost always see water coming off the compressor. Okay. Then you got to get, once it's a liquid, this is a centrifugal trap, or separator. Then this is just a trap, and we're trying to take out water and no air. And then this is just a manual drain. Somewhere there should be a manual drain. And so one of the things you should do on your visits is just see if there's water there. Okay. You might see a posi drain, which is, this one is a mechanical, it's actually an Armstrong 800 steam trap. Just a bucket trap. This is just a timer drain that's got from basically 0 to 60 minutes usually, and 1 to like 15 seconds. Typically around here you see them set anywhere from about 10 o'clock to 12, and these are almost always set right up there at 12 o'clock. Yeah?
On that, the float trap, do you ever have to pull it apart, clean it, or?
Oh yes, because there's almost always oil in that. In the air, there's a little bit of oil. The oil comes down here and it doesn't it just hangs that up. In fact, my very first startup in like 1980 or something like that, we started up a brand new 300 horse unit. Charlie, the service tech in Eureka, took this off of a brand new machine. He opened it up, put it on the truck, put it on the vise, went to his tool chest, got a triangular file, and right on the seat of that thing it goes. It's still common practice, right, Sam? He cut a groove right across the seat. And I said, Charlie, you just ruined it. He says, no, I fixed it. Because what he did is he created a leak so this would spit all the time. Because we were 5 hours from the shop out at a sawmill in Hayfork, California. It's near Weaverville. Anybody know where Weaverville is? Near Reading? Really about 2 hours from Reading and like 5 hours from Eureka. And he said, I don't want to come back here in a couple months. So he created a leak of a couple cubic feet a minute so he wouldn't have to do it. Now, why we are still using this 40 years later, I have no idea. We are, literally. That same Armstrong Type 800 or whatever, we still use. So that's why I say people like to test this to make sure that they've got a little bit of water. Now, they do require water to seat, so you'll hear them blow until they get enough water to lift up and start to seat.
You can also pre-fill them too.
Pre-fill them? Yeah.
There's a little.
Where do you do that, Sam?
This little guy will come out right there, and you can pour water in them if you don't want to hear them piss air off after you've taken them apart.
Yeah. So these don't plug up. These don't plug up because these open their little gate valve that pops up, and it goes. And if you've got a VFD compressor, it just goes. Because you just created a leak. It's going to blow right here on time for 15 seconds. Maybe 2 seconds is water and the rest is air. But what it did is it blew out all the scale. So I need you to show up every day and adjust that based on the weather. You know, every day somebody should check that and see that you're not wasting air. No, you don't do that. You just leave this about 9 to noon, and most people put it right here and they just look at it. As long as you're not blowing air for a minute, because you are just creating a big leak right there. Okay. Then we come out of the compressor, we go to those receivers, and then we need a filter. And that's to pick up any oil that came in. You'll see an inline filter like this. Goes into the center of the filter, it comes through, the oil is coalesced and drains out the bottom, and the air goes on downstream. You can see those anywhere from the size of your water bottle all the way up to this big and this tall. Depending on how big. The biggest thing we want them for is that I like them before the dryers. You have to have them before a dual tower. You get the oil out or it'll coat that desk in. That powder stuff, it'll just clunk up into mud if you get oil on it. I would rather replace these than heat exchangers and dryers, so it's a lot less. So I like the filter in front of it. Everybody in our industry says put the filter after the dryer, and that's because they said, oh, let the dryer, it'll take care of all that. We'll barely challenge the filter. And I go, the dryer is 50 times more expensive than a filter. Yeah. I'd rather change filters.
How often do you change out those filters?
Oh, okay. Sam, what do you think?
On the factory service program we have, where we come out to customer sites and change the filters, we do it every 1,000-hour service with the compressor. Other places go 6 months, some places go a year, some places just pull a canister off and look at it and go off of the differential indicator on top.
Okay, and that's where I was hoping you'd get to. There's some sort of differential.
Not all of them have them, a lot of them do.
So it's just a throwaway then, it's not something you...
Oh yeah, no, these are actually, it's spun glass, real thin glass that's all spun there, or it could be a paper element, it's just an impact filter
You just
to
take
do
it off
that.
and throw it away.
Yeah.
And then it's an O-ring seal housing, so you don't have to reef on it with a wrench.
Yeah, okay, good point. Thanks, Sam. Yeah, there's no ring up in there, and you should change that any time, but you just use a strap wrench and pull it over tight, but don't break the strap on it there.
On those O-rings, so I know in a lot of water filters, they usually supply like a jelly type to put on the O-ring. Do you need that with these?
Okay. What do you do, Sam? I've never had that
I
question.
usually just use the, the Parker O-ring lube, that's kind of tacky.
Yeah.
I use that on all my O-rings.
Okay.
Some guys use anti-seize.
And that just holds it in place?
Yep, you just slide
Okay.
it, there's a groove for the O-ring to fit into right above the threads.
Okay.
If you put a little anti-seize on the threads, it comes off pretty nice for you the next time around.
So you're talking about the threads right here?
Yep, the thread.
Okay, on the canister. Okay, good point. Be real careful if you're working on a hospital medical air system, or it's going to a food processing. You know, it should be food grade or whatever you put there. So maybe you have a little jar of Vaseline for sticky on there. It's not never sees, but it'll stick that O-ring in there. But just be careful if you're sticking something in there that's got MSDS sheets and all this other crap, and it fires off a sensor somewhere else. Also, if you're working any high tech, somebody said diffusion pump, those are used in high tech. And you be real careful what you use on air systems there, because they're real concerned about it. So these filters are there. The reason I like the differential is because it really is, when did I get loaded up? And, you know, some of these are just indicators, green to red, you know. And when I asked a couple of customers, when have you ever changed that? You know, I'm walking over there and I see it, and they said, it's always been green. When was the last time you changed it? I said, I don't know, it's still new, right? It hasn't changed. You know, it was like 5 years ago. And I go, okay. So what would you usually find? If somebody says that there is never a differential, there's about 1 of 3 answers here. Pardon?
It's clogged.
It's clogged, but if it's clogged, I should see it way over here in the red.
You don't depend on the volume used, really. I mean,
Yeah.
When you're in high demand, pressure drop's gonna be greater.
Yeah.
And if you're just idle, if you're checking it first thing in the morning, nobody's using any air,
Good
oh my
point.
shit, it's like, it'll be.
Yeah, you have to have movement for any kind of pressure differential, right? But this guy said, I go by it 20 times a day. It's never not in the green. Yeah, it could be plugged and it could have a hole in it. It got so tight, it actually blew a hole in it. Or it failed in third shift and somebody didn't have a filter, so they got to keep the plant running. They bypassed it, they pull it down, oh crap. This inner element is crushed, and they pull it out, but they don't have anything in stock, so they put it back up, and of course it's green. There's no filter element in it.
Or the reference tube for the little thing is plugged.
Or the third item is this guy is screwed up. You know, it doesn't read right. So we pulled it down. I've got the picture somewhere on my deal here, but it was crushed, and it looked like some snake that was dead, and a big old slit in it, you know, where it had failed. And so just be aware of that for something to look at. What are these? The bigger ones will almost always have a gauge. The smaller ones up to about 1 inch don't have it, because it adds like what are these? $100 now, Ryan? For if you buy a finite filter with that, $100 more. Yeah.
Less than that.
I can't even remember. These might be 200, and that's 50, and some guys won't buy them. It's funny, you know. It's your air system. So now we go into, I picked this picture because it shows a wet receiver. Here's a pre-filter. Here's a dual tower dryer, and here's an after filter. The after filter is collecting the dust off of that dual tower dryer. When you switch those towers back and forth, those little beads in there, they're little 1/8 inch or 1/4 inch beads, they're rubbing on each other, and they just sort of abrade, and it becomes real like a talc. You can't even hardly filter, you can hardly, well, you can't see it when it's heavy, but it carries down and you don't want it in your air system. So if you see a whole bunch of white powder coating this one, there's probably a problem with your desiccant. The other thing you'll notice on this dryer.
Is there a change interval for the desiccant?
Yes. In a dryer like this that's heatless, it is anywhere from 1.5 to 3 years, is what the book says. But Sam probably says you're not going to make it past, what, 2 years?
A desiccant?
On a heatless?
On a heatless dryer?
Going every 5 minutes? Although this is a heated dryer, there's a...
Heated dryer, I think they say 3 to 5 years.
Yeah, heated dryer, 3 to 5.
I can't remember what they say on...
Heatless is 1.5 to 3 years, but a lot of times you won't make it. You won't make it, especially if you hit it with oil, hit it with, lots of use.
Water will screw up your desiccant badly.
Yeah, oh yeah, and that's why I like the wet tank here. It acts as a safety from the after cooler the moisture separator, the condensate drain. This acts like a big separator also.
So you have your dual tower there, and then don't you have a secondary,
Receiver?
a secondary, filter?
Yeah, right here.
Oh, okay.
Yeah, to get that powder or that
Yeah,
dust.
and then you have something to monitor it down.
Well, there's nothing to really monitor it, but your inspections, every 3-6 year, you're gonna be pulling this off to look at it.
Can you explain how that works, what it's doing?
Yes, this fellow right here, what happens is, this is really 2 dryers, and it's full of activated alumina. And I've got a couple slides coming up, but what we do is we run the air right here, and there's valves here, and we send it, I can tell that it's going to this one because the gauge happens to be, they're both up. Yeah, it's coming here, and activated alumina has it's very dry. Remember I said it was like cement, it pulls moisture out? Well, it pulls it out of the air. The desiccant likes the water more than the air. So it jumps into the desiccant, you might say. It's not magnetic, but it's the same kind of idea. And so this air is going through here, getting drier and drier, and it goes on out, and goes on out into your plant. Actually, it goes out, and then over here, and then that way. Okay, the trick is, this tower is getting wetter and wetter and wetter, and so we call it the moisture front is slowly moving north. And when it gets up here, this fellow right here says, hey, we're not minus 40 anymore. We're minus 35, we're minus 30. The outlet air, that's what this is monitoring, is getting wetter. So we switch over to this tower, which is ready to go.
So it is monitoring, and it's
monitoring.
not a cycle time, it's based off of a sensor that's monitoring.
It does both.
It does both.
Depending on the model you get, it does both. The simpler dual tower dryers, the non-heated, they go on a time base. They switch towers every 4 to 5 minutes. Whereas this one has a dew point monitor that's going to tell it when we hit minus 11, whatever the set point is, it then switches that tower.
So if you don't have the monitor, how do you? I mean, you got to set up that cycle time, and
It's automatically in the program.
Yeah.
It automatically switches
every 4
hours. minutes.
On this one.
Non-heated, 4
Yeah.
minutes.
There's actually a switch right here that says demand or normal. Normal is time. And this is just monitoring dew point. It's not monitoring the desiccant or.
So that's the standard that has worked. Is that?
Oh yeah.
Because you said there's no monitoring downstream, so how do I know that it's working?
Yeah. Well, that's what I was just going to point out here. This is measuring the dew point, and it should be about minus 40 or deeper.
Well, that's great. I got one that's monitoring, so then
yeah,
I got some.
That's just that particular model in that particular sale, because that's a $7,000 adder, no matter what size of unit they get. So you get some people that are just buying a 200 cubic foot dryer, and they're not going to spend. The dryer is like $12,000. Why am I spending 19? I don't need that backup camera. I don't know, whatever you call them now. But when you get into bigger ones, this is a 400 cubic foot one. I'm surprised that's on there. About 500 is where most people start adding that stuff on. You probably don't have that monitor. On your smaller ones, if you have a 10 or 15 horse system, they probably have just a small one where the towers are this tall, they're about this big, and it just goes every 5 minutes. Back and forth, because it's low cost. It's low cost. Now the good thing is Seattle City Light will pay to put this on. Or pay when they buy a new one, you can get that incentive. It's sort of like going up to LED light bulbs. I don't know what these are. Are these LEDs?
They're off.
They're off. That's the most efficient bulb.
For medical clinics and hospitals and stuff like that, is there a standard?
They just have to be, I think the dew point has to be 20 degrees below whatever the expected ambient is gonna be. So hospitals go both ways. They'll put refrigerated is plus 40 basically, this is minus 40. Dew point. But I didn't finish up. When I switch over here, I now have to regenerate this tower. And what I do is I take some of my dry air that is going out to the plant and I backfeed it. And it's very dry. Remember I said it was very dry? And then I heat it up to like 350 degrees. So it's extremely dry. It's still a minus 40 dew point, but at 350 degrees, I run it backwards through here. So now I send in 350 degree air that is extremely dry and the moisture jumps off. It's being driven off. It's like baking it in an oven. And so this purge air comes all the way down here and it picks up moisture and then finally it gets into equilibrium and it just keeps pushing that moisture front down, 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 and out the back, I can't really see them here, there's some mufflers that is blowing it into the room. So we're venting that moisture that we picked up over the last 4 hours right there. So we have to switch back and forth.
How long does it take to do that regen thing?
On a heated dryer, it takes 4 hours.
Oh, so it does take 4 hours, so it's working the whole time to regen while the other one's...
Yes.
Oh, wow.
When you're in the timed mode, this tower is big enough to handle its rating for 4 hours to stay online. The problem is most people don't put them under full load, and they're rated at 100 degree saturated inlet temperature. So if it's 90 degree air coming in, we've cut out about a quarter of the moisture, so it could go 6 or 7 hours.
And those big tanks, you just change them out every 3 to 5 years?
Not the tank itself, just the desiccant in it. That cap there, and there should be one right here.
Shop vac.
Shop vacs work great. Shop vacs, it's really light stuff, and the worst thing you want to do is open this up and just have it sort of spill out like styrofoam beads, because they're like heavy beads. And
so there's no screen or anything there to kind of hold them?
Well, there's a screen in here, but the port has to be up in the middle to pull them out. You have to be able to have access top and bottom, because you got to fill it from the top, drain it from the bottom if you do it by hand. But the best thing is a shop vac with a real long pipe like this, and you get up on a ladder, and the problem is you got to empty that shop vac about 20 times, because it's going like that. So we've even hired, when we're in a mill and we got some 4,000 cubic foot dryer and it's got like 4,000 pounds of this stuff, we just get one of those evac trucks in. And they just run their hose all the way in and it's sucked out in 20 minutes a tower. And they're just running it because they got the big tank on it, the whole thing. Somebody had a question back here.
Yeah, when you're saying desiccant, is it kind of like silica?
Silica gel is a type of desiccant that we use in high-tech places. Most of the time it's activated aluminum.
Gotcha.
All right. Desiccant is like the terminology, I have an automobile. Do you have a Ford, do you have a this, or do you have a Mercedes? They all do the same job. Okay. I just put this picture in here to show you the filter. This is a great discussion. Thanks, Seth. Okay. Okay. So here's my dichotomy of dryers. And like compressors, you're going to run into basically either refrigerant or desiccant. And the desiccant is regenerated. And how we regenerate it is how we rate the dryers, or how we talk about them. Those are pretty much the dual tower dryers on the lower right. These are refrigeration dryers. All we do is cool the air, because it came into the dryer at 90, saturated, and we just bring it on down to 40 and wring the water out of it, and then we heat it back up in a reheater and send it out into the plant. And for people living near the coast, it should work great. People working indoors, it should work great. Sawmills, they want dual tower because they're outdoors and they freeze up and stuff. People in the Midwest like refrigerated, and you wouldn't think that in Iowa, but nothing's outdoor. It's all tilt-up concrete. Everything's 50 degrees or better inside, even though it's -2 outside. Okay. We may be done early, so this guy and these guys are, either they know it all or this is just going here. So let's talk about refrigerant dryers. Any ideas about what cycling and non-cycling means besides the obvious? Yeah, one's a cycling, right? One's a non-cycling. Yeah. This is the cheap one. This is a refrigeration device that never stops. The refrigeration compressor is always running no matter what kind of thermal load you put on it. No matter what the ambient is, no matter, even if I turned the air off and went away for the weekend, this guy is still running. Huh?
Just non-cycling is the one that's always running.
Yes.
You pointed at the cycling.
Oh, sorry. Jesus. It is getting late. That's why I bring these guys with me. Non-cycling means it's on all the time. And it's the cheapest way to do it. And if we don't have enough thermal load on it, we use a hot gas bypass valve and create a false load on it. It's sort of like the air conditioning in my house is getting the house down toward 40 degrees, and I open the door to create a load, even in the winter. I would have my air conditioning running now, and I'd just open the door, although that'd probably be just as cold, but, so we create a false load. Cycling works like your refrigerator. It pulls a thermal mass down and says, hey, I'm at my set point, 36 degrees, and I turn off. And because I don't have kids anymore, although my grandkids come over, they're not opening the door very often or anything like that. It might start up once an hour, and the thermal mass rises up to, 38, 39, then it turns back on and pulls it back down. So these are, cycling are energy efficient. These are energy hogs. They're running all the time. It's sort of like, I never shut my car off. I just put it in neutral and come into the house and wait till the morning, come back out and start driving. Puts a lot of hours on them. They're simple, but, and that's all we used to sell. Nobody would pay extra. These cost about 30% more. So if that's $10,000, this might be $13,000. If I put a bid in for a $13,000 dryer, Ryan will say you're nuts. You'll never get the order.
Yeah, but you never make up the money in your operating costs?
That's interesting, because in the Northwest, our power was so cheap for so long, you couldn't.
Yeah, water power.
Yeah, you couldn't. Yeah, with all our power, up until about 2000. Remember when we sent all the aluminum plants away? We were running out of power. Every ounce of water coming down the Columbia was going through a turbine, in fact, probably 20 turbines. We were not spilling any water except when they required it for the fish, and we weren't selling enough to California to get it back.
We were. Non-cycling's gonna cost, you're gonna sell more maintenance on that though, right? Because it's running more?
You would think so, but people just run them until they get to about 10 years and just buy another one. It's so expensive. The really big ones that are as half the size of this room, yeah. The $100,000 ones, yeah, they work on. But not the stuff in your range. You just buy new ones. Literally. I said 10,000. They're probably 20. What's a 100 CFM dryer, Ryan?
Cycling or non-cycling?
Let's go with the non-cycling, just the cheapest one that they might put in a building. 100 CFM, $3,000, $2,000, somewhere.
It's like 5. Oh,
it is? Jeez. I'm still in the 70s. Sorry. That's why I bring Ryan, because I can talk about prices and everybody wants to buy. I want that $3,000 dryer that Jeff talked about.
Yeah, no, 3,000 is going to be in your sub 100.
Okay.
50 CFM.
Yeah. But it's hard to hire people like us or you and justify. When you're in that well over $1 a minute, you're pushing $2 a minute, out to customers. We don't rebuild hardly anything anymore, under about 20 horsepower. So this might be the diagram. We've got an air-to-air heat exchanger. We got an air-to-refrigerant heat exchanger, the standard refrigeration system. And here is this hot gas bypass. It puts a load on it. And that's all we got. The cycling type has a refrigeration system, and it chills down a media, which then goes to the air to refrigerant heat exchanger. So this thing will shut off and on based on temperatures of the fellow. And if you're doing any kind of refrigeration, this should be pretty common on it there. All right. Now, dual tower, the desiccant, I already sort of explained, we got this wet air, and these are supposed to represent moisture coming in. It's as a vapor. It goes around this desiccant, which has very lots and lots of, I'm going to say cavities. It's porous. Yeah. I mean, if you could expand it up to a big rock, it would look like pumice, volcanic rock. And out comes dry air, but also heat. This reaction creates heat. Now, most of that heat just heats the air up a degree or two, but who cares? It just goes out into the plant. It goes from 90 coming in to 92 going out, something like that. And it gives up this little bit of heat. And then when we go to regenerate it, we're going in the opposite direction. We're taking some of this dry air and running it past the desiccant, and it's sucking heat out of the desiccant and off the steel of the tank. And a lot of times you can sort of reach your hand up and down and you might feel a little bit of temperature difference where you're in that, what we call the mass transit zone, where this process is taking place. Above it, it's already dry. Below it, it's wet. It can't hold anymore. So it's a process that is like turning off and on, a magnet maybe would be a way to think of it. Somebody would say, okay, well, there's no energy here, right? This is a heatless dryer. It's going back and forth every 5 minutes. The cost of running this dryer is the 15% purge. If I have a 100 cubic foot rated dryer, I have to waste 15 cubic feet a minute, which is basically just a leak because the air compressor has to supply that. You have to dry it. So maybe I've got a 100 cubic foot compressor, I've got an appropriately sized receiver, and I got a 100 cubic foot dryer with the filters and everything, but I'm only using 10 cubic feet a minute. So my compressor is putting out 25, the dryer is consuming 15, and 10 is going downstream. Yeah, go ahead.
And that's just when you're running the air back through it the other way to dry it?
Yes, that's the purge air that's regenerating the fella. It's regenerating. So it doesn't matter, it's 15% of the dryer rating, not of what gets delivered. Yeah, okay. So it would look like this. It's real simple. That picture I was trying to show you looks like this. So the air comes in, there's two valves, this one's open. I picked the wrong side of that other one. It's going up here, it's going through, it's giving up moisture, it's getting a little bit warmer, and it goes over and goes out. We then take some of this air, we run it through an orifice, and it's calibrated to this gauge. Now this is something you'll want to look at. If you have a heatless dryer, figure out where that gauge is. When it's purging, that's going to read somewhere around 35 or 40, but it is specific for each model and each manufacturer. And you'll almost always see a little bit of a line. Somebody wrote a line on the gauge because this is a manual adjustment right here. You'll see a little gate valve, you'll see a little guy, it's usually just a 1/2 inch line or maybe even smaller. And you will adjust this so that when this air is flowing through here, it's very close to zero because it's zero here. It may only be 3-4 pounds after this orifice. And what they want to know is what is the purge rate. So they just, that's real cheap. Just put an orifice in there, put a gauge and a valve, and we'll field tune it. Right? Some guys will say, oh man, I got wet air. And they'll open that up. And that 15% now went to 25% or 25 feet. I just did that yesterday. We're at an 1,130 foot dryer. And when one tower is online, we're doing great because that guy's purging. He's purging correctly, but over here, he's not. And you hear the VFD just ramp up 20 hertz. Goes from 45 to about 65. hertz on it to supply that extra. So that's the lowest cost, does the job, or whatever. We have heated type, where this air that I'm running here, I want to, instead of just using air at normal temperatures to do the regenerate, let's heat it up to 350. And now I only have to use about 7.5%. But you don't see these until you get to 500 or 1,000 cubic feet, you know, big compressors. You'd never add a heater on a little 100 horse or 100 CFM. I don't think you can buy one, can you?
Cubic feet heater.
Pardon?
What's the cubic feet rating for pressure usually, or is it standard? Is it like 90 PSI or 110?
Oh, generally, you're looking, almost everybody wants 100 pounds.
Okay.
You know, we're trying to get people to run their plants at 90.
But when you're saying 100 CFM or 500 CFM, you're talking about at 100 PSI.
Cost is still
At 100 PSI.
less than.
Because it goes up quite a bit if you have less.
than,
Like if you
Okay.
Look, if you look at the store.
Is it more efficient, I guess? I think it's basically you're offsetting, you know, compressor amp load versus heater amp load.
The heater. It's much better to run the heater than it is the compressor. Because the compressor, I'm gonna get right back to you, Brian.
Yeah.
This guy creates heat, and we use it all. The air compressor is only 15% efficient thermodynamically. If you have a compressor, the horsepower here is only 15% of what its motor is. 85% of a compressor's energy goes as heat. That big radiator on the compressor, that's where all the energy goes. So if you have a 10 horse air compressor, 8.5 horsepower is going out as waste heat, and only 1.5 horsepower is coming to here. So if you want to use the compressor to generate compressed air to regenerate it, it's not as efficient at all. Now, let me get back to yours. And that is much more basic than we rate cubic feet per minute at atmospheric conditions. So if we have 1 cubic foot here in Seattle at 14.7, and we run it into a compressor, and now it comes out as this little guy, 1/8 of it, 1/8 physically, it's been shrunk 8 times, we still call that 1 cubic foot. Because we assume that we just re-expanded back to the 14.7. It's something that our industry does, and it's, can I say this BS? You know, in my opinion, our industry is trying to confuse the end user, the customer. Not you guys, but the customers. And so we have different standards, we have different ways to call cubic feet, we all have all kinds of different things. You know, we live in an economy where if you buy a gallon of gas in Seattle, it's the same volume in Iowa, hopefully, right? We have weights and standards. You buy a pound of hamburger here, you buy a pound of hamburger, you know, in New Jersey, it's still the same. We have a weights and measures, but that's not the same in air. We have different standards, you know, we use different scales really, but most of our compressed air equipment is rated at atmospheric conditions, which means we don't care if this is 90 pounds and it's 1/7, or it's at 110 pounds and it's like 1/10. We still call it 1 cubic feet, no matter what physical size it takes up. I don't know if I made sense there, Brian. Now, there's a couple exceptions to that, as always. When we're dealing with pipe friction, we have to deal with velocity, so we have to know what pressure it's at. When we're dealing with resonance time inside of here, I have to know the velocity. Anytime I have to know the velocity, I have to know the physical cubic feet per minute. For instance, this dryer may be rated 100 cubic feet at 100 pounds. If you give it 125 pound air, it might be rated at 120 feet because it's just crunched together. And the velocity, and they're really worried about contact time there. But if it's only 90, this thing gets derated. Okay. I don't know if does that make sense? Yeah. If you don't, I have a whole 8-hour class and I'm teaching at Longview next Thursday. Yeah, next Thursday all day. So.
It's all up.
Or you can just ask me and we can.
Yeah. There you go. There you go. Brian, I don't think I gave you. Hang on. At the end there, he's already had 3, so.
Cut off.
Now you go out into the point of use, you'll see lots of things like this. 3 items in a row. Does anybody know what these are?
Filters.
Yeah, one of them's a filter. That's a good shot.
Water.
Well, that would be the filter. Here we go. Alec? Yeah, you're the first one. Say what? Oil separator, that'll happen in the filter. Yeah. This is the, it's going this way. Here's the shutoff valve. So this is a filter, and if you caught any oil or any moisture, it might be there. Most pieces of equipment, this is out at near your piece of equipment, they will run on anywhere from 60 to 80 pounds. So everybody likes to have nice constant pressure. So this is a regulator. Like, what are your pneumatic HVAC controls running?
25, 40.
Yeah, you've got to have something like this in the way. And then, to make matters better, if it is a pneumatic tool, like an impact wrench or a gun, this is a lubricator. This guy is full of oil. And it's designed to put machine oil in. Right? You have to lubricate tools and stuff. And they have a little glass bulb on the top, and generally there's a little drip here. When it goes by, it pulls a vacuum and puts a little bit of oil. Most likely you don't have that. In buildings or anything, we're doing everything we can to get rid of oil. And here we are putting oil in at the end. So this would be in a machine shop, you know, a welding shop. It'd be in my house. I should have one. I don't. I just wear them out.
A lot of times it'll be like local in the shop, so you'll have
Yeah.
like in a specific room or over a bench or whatever.
Yes, exactly. These are very close to the point of use because this oil wants to be a vapor or a mist, and it's trying to settle out in that pipe. So when you pull that trigger, there should be a big coil of red rubber hose here, and you're within 20, 30 feet of, you know, doing something with it. So this is what we're trying to clean up out at the very end. That's the whole purpose of this slide, is to tell you about contamination, because you may have any kinds of scale or anything like that, especially an older building, any kind of stuff. I mean, you must be working on systems that could be 30, 40 years old. Yeah. They're generally smaller. They're almost always in groups of 3, and they're almost always missized.
Or leaking.
Or leaking, good point. Yeah, this will be busted off, that's leaking. Most people always complain they don't have enough air, so they just crank this all the way up to 100 instead of getting it set where it should be. Almost.
Usually because they have leaks in the system somewhere.
Yeah, or just on their hose. They got too long of a red rubber hose trying to give it. When we look at gauges, when we pull the trigger, instead of having 80 pounds, which this might be set at, it drops to 40. And they're not getting any torque. And they're not getting their bolts in or their screws in or whatever they're putting in there.
I worked at a place that was running staples.
Yeah.
Omega Morgan. And they had all their boss ditch guns running like 125. The problem was the regulator was 125, so they cranked all the way up.
Yeah.
So they were failing, so I put in like 150s or something like that. So they weren't at the top of their scale.
Yeah. What you'll often find is channel lock marks on this. They actually build, this is Wilkerson, I saw that. They actually build regulators that this knob doesn't do anything. Non-adjustable regulators.
You take it off and adjust it?
Yeah, tell me if you use that.
Yeah, there's a set screw or something in there that works on it. Every time I go into the field, those are always turned up, and all it is a pressure drop, problem. When people complain about lack of air, they want more pressure, they said. But really, they say, I don't have enough pressure to get my job done. What they're really complaining about is I can't get the air there to do the job. And that's usually some restriction further on down. I'll show you a couple of videos of some stuff we've done. Here's where you'd find them in a system. Out here, they're almost always the same size wherever you are in the plant because purchasing got a great deal on 1/2 inch FRL, filter regulator lubricator, on it there. Or they got 1 inch ones, or they got 1/2 inch ends where they should have 1 inch. I mean, it's crazy what they do. One thing I do want to point out is this is a best practice. If you've got a piping system, come off the top, like sort of a candy cane. If you pull it off the bottom, what's going to happen? Yeah, the water, oil, scales just falling in. It's not supposed to. It's not supposed to, I know. It's there. I just put that in there so you can see that they are in every system. Ah. Oh, here's my favorite subject. This is, so how do you know if a recip is putting out? One of the most common calls is my compressor won't keep up. What's going on? And it's a reciprocating compressor like one that I showed earlier. So guys like to do, you can't do an orifice test. Flow meters are expensive. So what's a simple test that you can do that will...
Test them for
Amp
blow
draw.
by?
Pardon?
Amp draw.
Amp draw would tell you that it's running, and if I've got too much load, but the cycle time, whatever, yeah. What I'm going to do is time this compressor to fill, and this is key, an isolated tank, and the assumption is there are no uses or no leaks, that all the air on the compressor is going out into that receiver and it's building the pressure over time. And you have to know the vessel size. From one pressure to a higher, from either the cut in to the cut out, or from 0 to the stop pressure, or stop to start pressure.
And ideally, you did that when you first installed it.
Pardon?
They said ideally you did that when you first installed it.
Oh my
so you
goodness!
have
Yeah,
a
you're
baseline, so now you can watch it.
base. Did you hear that baseline? What does that mean? He does get an extra one for that. It means you're going to trend it. It means that you're going to do this once a year, right? You're going to do this once a year. So I'm going to draw this now. So I've got a compressor. Let's say is a motor, and it's belt driven. This is why I went into engineering, guys. I cannot draw. So here's a compressor, and here's the intake filter. And it comes out of here, and I'm just going to have it going into a tank. And out, well, it should have been, that's higher. So you're going to close this. So you'll have to fire up the alternate one, and hopefully you can do this. Or you're in on a weekend when they don't need the air for about 20 minutes. So you can do this. And you're going to time it from either 0, you drain it all the way to 0 and all the way up, or you're going to start and run it here. And I think this example is going to be, okay, and here is the formula, and you've got it in your handouts. The CFM of that compressor is equal to the volume of the receiver times the pressure rise from the low pressure to the high pressure, so this is a positive. This whole thing divided by how long it took, that's delta T, times 14.7. Except I realized that I used an asterisk in the last one. An asterisk in Fortran is a multiplication sign. We don't use X, because that's a variable. And I'm just in the habit of every time I want to say times something, I put an asterisk in there. Most of you guys probably don't know that, because what's Fortran? Huh? It's a dead programming language, yeah.
Wow.
Yeah, that was definitely the 70s. Yeah. So, wait a minute, you're starting to tell me how old you are. Yeah.
It's like that. Yeah, 80.
I actually punched cards for my work in college. So this formula has a couple of tricks to it. Here's another weird thing about our industry. We sell air compressors by cubic feet, output, but we sell receivers by what? Gallons. Yeah. And so that's another one. So this formula is in cubic feet because that's cubic feet per minute. So you got to convert. 7.48 gallons is equal to 1 cubic foot. This delta T is in minutes, right? But your stopwatch or your watch, or maybe your phone, and they got stopwatches in them now, right? Are usually in seconds and minutes. You got to convert all that to minutes as a decimal. P2 is the final stop or cutout pressure. P1 is the beginning, the start, or the cut-in pressure, whatever you want to do. And those are in PSIG, and their units will cancel. So, and that's because this is in PSIG also. Actually, no, it's A. It's A. But it doesn't, it's in PSI, PSI, PSI. Whichever one you do, you gotta be consistent. Okay, it's the difference of them. So let's look at this example. A Quincy Rodgers package, it's called a 350. It has a 10 horse motor on it. It runs stop start, and it's a reciprocating compressor. It takes 170 seconds to fill a 240 gallons, so I gave you that. So this is 240 gallons, though, which is a real common size. And delta T is equal to 170 seconds. So, and it went from 135 up to, what did I say? 175. I'm working without a net here now because I took the answer sheet out. The guys, they were real smart last time because they told me the answer and I said, you did it that fast? He says, no, it's in the next slide. And so I took it out. So who can tell me the output of this machine? Who's working on it? You can work together in pairs. So right down now, you want to know, did I sit next to somebody that looks real smart? If you don't like this kind of stuff, who's the math guy? Who's the guy you're supposed to call? Mark. Or you can call Mark. Ryan.
You Google it.
You Google it. Okay. By the way, there are apps for this exact thing. Maybe you know the CFM, but you don't know how big the receiver is. Whatever you don't know, it will solve for it. You put them in and it just keeps solving for it. There are apps for this. I forgot about that. Good point. Huh? There you go. That's good. While they're working on that, I'm going to go get those parts. Or no, we're about ready for a break anyway. What do you get? You guys got to do this.
What do we do?
What's the output of that machine?
What? I'm finding my pump up test thing.
Okay, you got it.
I'm working to have that put on our website.
Yeah, that's a good idea. Some formulas. I have a spreadsheet, but I also can do this stuff, I just generate the formula each time.
It's not what you know, it's your research.
1723, 1724.
Yeah. By the way, I think it's great that you guys have these kind of classes, every 2 months or something?
Every week.
Every week?
Different class.
Oh, they should have beer in here. Where's the refrigerator?
Just a tap over on the wall. I may have said it somewhere.
Yeah.
You did.
Well, the deal is you got to learn new things for your career. The days of coming to work for one place and working on one system for your entire career and retiring has long gone. They look like they got answers in the back. What did you guys get in the back? What'd you guys get?
I got 1724.
I got 30.2.
Yeah,
We got 30.2. You probably wrote a spreadsheet, right? 30.2. And what are the units?
Did you have a spreadsheet?
Yeah.
Okay.
Cubic feet per minute? You did look up something, right? Did you download a?
No, I didn't.
Okay. Okay, this is Algebra 1 from, is it freshman high school now? No, they're doing it in middle school now. But some people either like this stuff or don't like it. And okay, how many gallons is it, or how many cubic feet is this tank?
32.
How many cubic feet is that tank?
32.09.
I know, but
32 what?
170 to check out.
Yeah.
170 times 4 is times 4.
Divided by 7 point.
Divided by the.
Everybody else get that? I am working without a net here. Is that right? I didn't bring my notes.
It can't be half scale.
Now that's the size of the receiver.
Yeah, I just did 32.
So that's
240 gallons times 7.4 acres more than that.
divided by 7.4.
Yeah.
Oh, yeah, shit.
Cubic feet are bigger. Yeah, boy. Glad I'm not the only one who did it. See, I called the cycling and the non-cycling. I'm calling them and pointing at them. Yeah, I just got to remember who's bigger, a gallon or a cubic foot. Yeah, so you got to divide. So that's why we went from here down to here.
We're so far off.
It looks pretty good. Wait a minute, we're so far off. I don't like those things. You guys weren't firing missiles. Yeah.
Sorry.
Syria now, were you?
Yes.
Does this sound right? 32 is the size of that tank? Okay. What is this worth in minutes?
2.83.
I got 31.19.
I got 30 estimate.
30 what?
See if
Okay. So you like this number too, okay? So delta T has been converted to minutes. Gallons has been converted to cubic feet. What's this number here?
40.
Okay, that's 40. So I think we have everything now, right? Let me back up. One spot. So the volume is 32.09 times that 40, right? And it's 40. Okay, and then we divide it by, notice I put the parentheses around here so that you have to do this operation and then divide it into that. Let's see, what did I say that was? Delta T is 2.83, does everybody like that?
30.83.
And times 14.7 is equal to CFM. CFM, that's great planning, Jeff. So that looks like 1,200 on the top, and that looks like about 45-ish on the bottom.
41.
How much?
41.6 is what I got.
On the bottom? How about the top?
1283.6.
12 what?
Just put 1287.
1286?
83.
I had 1280. I don't.
Yeah.
32.9 times 40.
That's it. Okay, and that equals, yeah, it's looking pretty close to the 30.
30.85. Sure, I got it.
Oh shit, they have to make that 7.
Yeah, pretty close. Now, the other question is, okay, that's the output of the machine, but I forgot your name. I was gonna say old guy, but that's not.
Smart guy.
Whoops. Okay. What is the compressor flow rate? That's good. 30.2, 30.85, and the key is the trending. Do that because, quite frankly, this isn't exactly 240. I got this little bit of pipe here, I got this and part of the valve. If I was NASA, I would be calculating all those little extras and putting it into my spreadsheet. Does this compressor meet specification? We don't know, because you gotta call Ryan, and Ryan's gonna tell you, he'll look it up, and I believe this is,
You're pretty close.
it's 34 or 35, it's a little bit low. I think it was 94% of spec. So whatever, 90, I can do that. I'm working without a net, guys, so. What did I say, 30? Yeah, it was about 33 is rated. Yeah, and that's because it's a 175-pound machine. You had to slow it down. So this is not far off. It's not far off, but the real key is to trend it. It's like Mark, right? Mark, you're talking stuff, okay.
And that's the.
He's got Seth right now.
On Seth, okay. So, does this compressor meet specification? It's close, it's real close. But again, this is not exactly 240 because I'm not counting that pipe, I'm not counting that. Might be a little wear in the rings, probably not rings. The valves could be getting a little old. When you start seeing this drop toward 25 and 20, you got a valve problem. Almost everybody wants to do the rings on a piston machine because it slows it, but it's not the rings, it's the valve allowing air to come in, and because it's got a chip out of the valve, it just goes right back out the intake. Is where you get big dramatic drops. So a common call is my compressor won't stop, I'm running out of air, what's going on? Now, you could do this pump up test or you could look for what? A leak. Because most likely, you're gonna close this valve, do your pump up test. Oh man, I don't really care about all this math, I just care about this number, that's what I'm measuring. You know, oh my God, it's taken 300 seconds. That's way too long. What you really wanna track is this number, that's what you're measuring. And if it's within that 170 and that's what you baselined it at, you know, maybe you write it on the wall there, I don't really well. Back in the Sharpie a little bit. Okay. So, at any rate, let's talk about controls.
Maybe take 5.
Oh, I'm sorry, I forgot completely about the break. Yeah, let's take 5, come back at 20. We must have a smoking policy somewhere, they gotta be outside or something.
Oh, wait, encourage
I'm gonna go to the car, I had a few,
I did, yeah. I'm gonna look at like, hey.
Then you better get a smaller compressor.
Better get a smaller compressor if it's gonna run all the time, or you have to control it. And almost all compressors are oversized because our demands are going up and down, and we have to have rest cycles on especially reciprocating machines. So, of the 3 types of compressors you are most likely gonna run into, 95% of the time, they are reciprocating. They could be oil-flooded rotary screws, or they could be oil-free rotary screws. And really with reciprocating, there's only 2 ways they run. Stop-start, you just stop the motor, you start the motor when you need air. And that's just sort of what that pump-up test did. We let it idle down, and as soon as it turned on, we closed the valve, and we watched it pump up. Stop-start. When you get a little bit bigger, we have load-unload, where we let the motor keep running, but we don't let it make any air. We hold open the intake valves, essentially. And the air just gets sucked in, and it gets blown out. The air filter, sucked in, blown out, sucked in, blown out. Air pressure decays, and we reload it. It loads back up. Oil-flooded rotary screws are the ones that have the oil injected into, and I've showed you a couple of pictures of those. We have load-unload, we have VFD, but most likely you're going to find modulation. Modulation is where we use this little valve right here, and it's set by this screw, and there's no gauges or instruments on it. You just watch the machine and it's modulating. You look at the gauge, okay, that's the set point. But what it does is it controls the inlet and closes off the inlet and opens it up when the air pressure starts, and it's like cruise control to keep a constant pressure downstream is what it's trying to do. It's the simplest form of controlling an oil flooded screw. It basically starves the unit like a choke on a car. Just starves the unit. Hey, if it's pulling a vacuum, and that's what it's doing, I got atmospheric up here in the air filter, I come past this valve and it's only 7.5 pounds absolute. It's half a vacuum, or it's 30 inches HG. It takes 2 turns of the screw to get the same as 1 turn if it's fully open. So there's fewer molecules going downstream. We can also load and unload them, but that's a complicated fellow. A lot of people don't like to do that because almost nobody has a big enough tank. You see, this tank is almost big enough. This compressor is putting out 30 cubic feet a minute. This is 240 gallons. We like 10 to 1. 10 to 1 is a good rule of thumb. Okay. Boy, they got real quiet all of a sudden. They're thinking, huh, we got an hour more, right? It's 6:30? Okay. How much more can he talk about? Okay, and when you have bigger and bigger machines, like 500 cubic foot, 10 to 1 becomes what? A 5,000 gallon tank. You have 1,000 cubic foot compressor, now I'm starting to look like that one I showed on a truck real quick. And you can't get those down the stairway, can you? They're just just chop it up and re-weld, yeah, chop it up. Okay. VFD has become extremely popular for load unload. They just speed up, slow down, and they're like cruise control. However, they are energy efficient when they do that. When I use modulation, I am turning that compressor into a really stiff compressor because I'm making it compress from a vacuum up to atmospheric, down part of the rotors, and then up to 110 pounds. It's doing extra work. The power is going down, but not by very much. And I'll show you some graphs of that. VFD is very proportional, and people like it. I just slow down, speed up, because I am slowing the screws down when I don't need as much air, and I'm speeding them up when I need more. So we shouldn't do that with. Okay. Oil-free rotary screws are controlled the same way, except they cannot use modulation. We can't starve it for air because we use the compressed air for cooling internally. We don't have oil in there, so that heats up to about 400 degrees in there, and I got to have air going through to take care of that heat. So those are the control items I can do. So let me go with reciprocating real quick.
I took care of an Ingersoll Rand that was a screw that it actually cycled up as well as
VFD.
No.
What horsepower was it? Like 10, 15?
Oh, it was 25.
Okay. What I didn't put right here was load unload, and when it's unloaded, it starts a timer, and after like 15 minutes, it will turn off. Yeah. If you have this thing pump up and he unloads and he stays there and he's not needed, say you have 2 units there, you can put what's called a overrun timer or an auto stop timer on it there. Yeah.
Yeah, because it was massively fast.
Yes, exactly, and it would stop. VFDs now are so good that they can actually just stop the VFD. Well, instead of unloading it. If I'm down at minimum speed, I can just turn it off and just have it sit there and wait, because the VFD acts as a soft start. Yeah. So let's take a couple looks here. Back up.
Sam mentioned to me that as far as like scroll compressors,
okay,
those are becoming more common here in Seattle. As you're talking about the reciprocating, they are oilless compressors.
Yeah.
but as far as the reciprocating, the start-stop.
On the Power X and,
You might wanna mention those
yeah.
as well.
Yeah, I didn't really talk about those. I didn't think they were very popular. You're gonna run into scrolls probably in hospitals and smaller units. They're like in 5-horse compressors, and you can stack like 3 of them in a cage, really. And you can have basically a 15-horse compressor. Anybody have those scrolls?
On refrigeration.
Yes. I know it's a real popular
I take
thing.
care of the guys. Rotary beam, both on the vacuum and on the medical air.
Yeah.
They look the same.
Yep.
Except one's medical air.
Yeah, I'm working on the 90% of the market. There's gonna be lots of little special. Remember that whole diagram of compressors on page 1 or page 2? Or slide 1 or 2? There's a whole bunch down there. There's rotary lobe, there's scrolls, all kinds of stuff there. But the reason the medical guys like scroll compressors in those small amounts, number 1, it's cost. And number 2 is I can have 3 5-horse units and I can rotate those. And I meet NFPA 99. I have to have redundancy. So I can have maybe one running, then maybe a second when I need it. When I shut it off, I rotate them. And they get their cool down time. So operationally, they work very well to meet all those requirements. The other downside is that you gotta do a lot of work on them. You gotta do those tip. How often do you have to do those, Sam?
5,000 hours on high pressure, 10 on low pressure, correct?
Yeah, that's a lot of hours.
Filters every 2,500 hours.
Yeah, that's pretty long.
And their longevity is a lot less than.
Yeah, a lot of them just get replaced. Yeah. Reciprocating compressors often have, for stop-start, they just run on a pressure switch, like this. Okay? And the pressure switch just opens when it gets up to 175 or wherever the cutout is. Maybe yours is 100, and it restarts at 80, like that. Now, you may want to adjust the pressure on it. And so I've got 2 adjustment screws. And here's the big fallacy that always happens with these. They always think this is the top pressure and this is the bottom pressure. And that is not the case. This guy moves them both together. This guy adjusts how far apart they are. Yes, the band. What else? What do you call it?
Differential.
Differential, yeah. So watch it before you adjust it. See what the differential is. If it's right, 20 pounds, if that's what you want, or if it's 40, whatever you want, then just play with the big one. Because once you get this screwed up, you basically got to take it off and bring it in, or you just buy another one that's preset. Literally. We'll set them, we just put them on our board. I just run them on a regulator. Click, click, and I'll make a couple adjustments. And basically, in about 5 minutes, I've done 2 hours of standing there watching this system pump up and down. Because I can simulate air pressure going up or pressure coming down on my shop compressor. Real easy. Okay. I don't know. I used to do them for free in Eureka. I don't know what you guys do. Did I just give some?
Most of the time, if we're adjusting them, we're in the field doing it as well.
Yeah. Yeah.
Or you can buy them preset off the shelf, out of the box.
Yeah, 145, 175, or 80 to 100, but basically they're all the
And you
same.
can buy them with just the differential as well.
Right, you can buy them, yeah, with just, like this little guy only has 1 screw, so it's real easy. It's a fixed differential and you just move them up and down. That's a little tiny guy. It looks more like a pressure switch you'd see on a pump. Anybody have a pump house for their house or anything like that? It looks like that switch. These are the big industrial ones there. Now for load unload, you may see this. This unloads the top head of that compressor. The motor keeps going, the pressure switch is still closed, but that's called a variable differential pilot, or VD pilot. And generally you find these on larger reciprocating compressors because I can't afford to stop and start that motor all the time. I only get a couple starts an hour, maybe 10 starts, 5 starts on motors if you read the manual on the motor. You guys do that, right? You read the manuals when you gotta go to sleep, or you got them in your bathroom. My wife really got torqued. I had compressor manuals in our bathroom. And she was just torqued when people would come over and they'd see that and they'd just start laughing. But what it does is it sends an air signal up to the head. It holds open those intake valves. And so the machine keeps running, but it's not making any air. The air is going in and out, in and out, in and out, in and out. Meanwhile, this pressure is decaying. When it gets down, that pilot releases himself and it goes off there. Now it has 2 adjustments and 2 jam nuts, and I swear if you start messing with those, you'll have it all screwed up real quick. Real quick. I have to do these on the board at work. I can't do them in the field. I don't even mess with them.
You can adjust your cut out, in and out pressure real easy. It's the differential.
Yeah, sometimes you'll see this little handle up here. When you rotate it, it pulls this pin, which unloads the machine. You can manually unload it on there. So if you see those, if you get more, if everything's all set up and you're wondering if it's working right, it probably is.
The top one, right below the lever is your cutout pressure.
Okay.
And then
that's a jam nut.
That's the jam nut, and then this is your differential and jam nut.
Yeah.
Screwing it in increases, screwing it out decreases pressure.
Yeah. It's one of those things you want.
Those?
Yeah.
Yeah.
If you
one of those
avoid
things.
Not doing a differential, I recommend it. It's a pain in the ass.
Yeah. Yeah. It's the best thing to leave to the professionals. I would call on that. I'm sure there's a YouTube on how to set a variable differential pilot, but at any rate, one of the things we like to see when we're running pressure switches, stop start, or using pilots is about a 60% duty cycle or less. Compressors, especially piston machines, need time to rest and cool if you want any kind of longevity. You turn them on and run them, these heavy duty Quincy's, they'll go a year probably, and then they'll break a valve or do something. If you do that to your Home Depot compressor, it'll last till probably tomorrow. They're just little reed valves and they're aluminum heads and they just get hot and burn up. So 60% duty cycle might mean 3 minutes loaded and 2 minutes unloaded. And then this is where we stop after 15 minutes. And you might put in a 10-pound control band, you might put up as high as a 40. So if you start seeing your compressor and you got your watch, this thing ran 9 minutes and was only off for 1. Either, so this is in that part about common calls, either they are using a lot more air down here, by the way, this is no longer closed, either they're using a lot more air, or this guy isn't putting out any air, enough air, one of the two. So that's why I like to, if somebody calls and says, hey, I gotta do a pump up test, and you already, Mark, have already said, hey, it was 170 seconds. Then you close that valve and it's 180, okay, no big deal. 165, something like that. The compressor is good. What are you doing downstream? And that's where it almost always is. It's the dryer, it could be a broken bottom of, remember that Ryan said, bottom of the filter could be broken. Somebody's got something open somewhere in the plant. Oh, we never use any air out there. Or no, we fixed all our leaks. You get that? You get that? Yeah. Go in there on a Sunday and walk through. It'll sound like a house of snakes, right? They're all hissing at you. So 60% duty cycle. So if somebody has a 5-horse load, we ought to see probably a 10-horse air compressor. So it gets time to turn off. Okay.
It's probably worthwhile when we're talking about leaks to let them know that you can find the leaks with an ultrasonic leak detector. You guys know that?
Yes. Go and listen for leaking.
So there's a little device called an ultrasonic leak detector. It is dialed into the frequency of compressed air leaks. It's not a frequency that you can hear with the human ear. The leaks that you're hearing with the human ear are leaks that are disturbing something else around it. With an ultrasonic leak detector, you put on some headphones, and you can walk around. The headphones mask out ambient noise,
And basically, you'll hear just kind of like hissing sounds when you come across a leak. It'll be quiet, quiet, and you hear kind of like a standard.
It's like a Geiger counter.
Yeah.
To do that. And what I'm looking for right now is a real nice picture on one of those.
Is this your 8-hour class?
Yeah.
Pretty much get the gist of it.
We're getting Yeah, well, this is the big one right here. With our power costs, $200 a year. If you have a system that's running around the clock or it's always pressurized, you can't feel $200. You might feel $800 and $1,400 a year before you can hear it. You hear about 7 cubic feet a minute is about where you'll start to do it. And so,
Interesting.
So now, ultrasonic leak detector, that's just a picture here. When this goes from a laminar flow to a turbulent flow, as it goes out through that orifice, it creates noise in the 20,000 hertz. We hear in the 7 to 12. Dogs hear up around 15. Some young teenager gals will hear, up to about 10. And the reason is they don't have testosterone, which hardens up the bones in your ear. So people like us that are getting older, people like me that are getting older can't hear as well. And they don't do it. So this thing just simply hears those things and converts it into a noise we can hear. We were trying to figure out if we could train dogs, little chihuahuas, leak finding dogs, or something like that, because they can hear it. Well, they hear stuff we don't. Dog whistles, like that. I had one guy ask me,
And I'm wearing headphones.
Yeah. At any rate, and they're not, the louder the sound means a bigger leak, but it doesn't mean, that's an 8 cubic foot leak, that's a 7 cubic foot leak. You can just sort of get small, medium, large, is about all. You can also hear vacuum leaks.
Leak is a leak.
If this is a vacuum chamber or something you got coming in, you can get some noise as this accelerates to go in there. And a lot of guys are using those because vacuum is even harder to find. It's very hard to find. So,
at any rate, there's a cost to leaks and there's a way to find them.
Yeah. Yeah, they're, I think ours, we have one, it actually has a camera on it, so when you zoom in on it, then you just go click. The biggest problem is getting them fixed. It's real easy to find them. So if you're really slow and you want more work, get a leak detector.
How much are those?
About $3,500 for a really good one with a camera. That they do make them down in the.
Right now, we're looking at request.
We've got
cheap
man.
You can use my cheap one.
Yeah, Travis has one, there's one in Portland.
Yeah, you can buy them for $500, and you know what? You'll find 90% of them.
Yeah, we got them.
They're like electrical.
You need 10.
They're like electrical meters. You can get a CT meter now for what? $75, $80. They used to be $10,000 when I started, and they would sit in the electrician's room because they were so expensive under lock and key, and nobody used them. They're so cheap now. They give them to all. All of you have a voltmeter with an amp clip on it or something for about $100. And off you go. So leak detectors are the same way. Okay.
When's the last time you updated your Windows?
Pardon?
How old is your Windows?
That's an 03, I think. Our whole company is. They've been promising upgrades for 5 years. So. Okay. Everybody was complimenting them on my big tablet. My IT department wanted to throw it away, and I said, like hell you are. That's the greatest thing for collecting data. So now, on oil flooded units, we have a screw we have a separator tank, we have an inlet valve, and here's that pilot valve, and we just control it right here, and it's driven off the pressure in what's called the oil separator tank. And that air pressure from this valve, we put air pressure here, and it starts to move this piston down, which pushes this plate closed because the air is coming in here and going down into the screw. We also have some that are butterfly valves that are really old. They have a rack and pinion on them. And really, the nice thing about this, if you want to know what its capacity or its output is, there's a gauge right on the panel. It says percent capacity, because it's measuring vacuum right here, and it knows how deep I've restricted it. And we just took a vacuum gauge and labeled it 100% is atmospheric and 0% is full vacuum. I think we still own the patent on that, so it's really cool. There's a picture of that differential pilot and how it works. So you've got this. It's really easy to adjust these. All you do is back up this jam nut, screw that in for higher pressure, let it out for lower. Now that I've said that, we'd ask you not to go messing with it too much, because if you go too high, as you turn these screws, the motor has to put out more power at a higher pressure. The harder those screws have to push against, the more power it takes. So you better have an amp meter on it while you're adjusting it, so you don't overamp the motor. Because we put, those compressors are designed to basically draw a 10% overload already. So 20 horsepower motor is drawing 22, service factor is 23, top of the service factor. So you can go too high if you don't watch it. So that's oil flooded control system. The VFDs are quite a bit more popular now. Instead of modulating the intake, we simply slow the screws down. Now we can generally come down to a spot, and then I can't go any slower, because if I get them going too slow, the oil just falls out, and there's no seal, and the air just slips back and gets recompressed and gets hot, and I require more power for even less and less air, and pretty quick the drive trips out. So usually about 30 hertz is about our minimum speed. 20, 25, some machines we can lower a little bit more. When it is within the speed range, it's considered loaded. The intake valve is open, the screws are doing all the adjustment. When we get down to minimum speed, I can't go any slower. Pressure's starting to rise, I may just modulate and starve it. Now I'm just starving a little machine, not a big machine. And there's nothing wrong with modulation other than it costs power. It's, if I got some time to do it. Now let's jump over to oil-free units. I don't have any oil being injected into them, so I cannot modulate them. And the reason is the oil takes away the heat of compression on an oil flooded. On an oil-free machine, I have no oil, and the heat shows up in the compressed air. It's very close to adiabatic compression. So it goes toward that 488 degrees. It goes toward it. And if I close this off, the temperature just goes higher and higher and just trips out. So what we do is this valve is either open or closed. Open or closed. For load unload was the standard way we did things for a long, long time. And then VFDs came along, so we put those on. You might see these in universities, hospitals, biotech, pharmaceuticals, some food processing. We have oil, our food grade oil, but it's still oil, Hey, if it's a French fry, no big deal. Yeah, we can, I guess we could have flavored food grade. But everybody now is going toward oil-free if possible and practical.
Costco's pushing them.
Pardon?
Costco's pushing them to oil-free.
Yeah, that's the reason people don't like oil-free is, I thought you said cost.
Costco.
Costco. Well, the cost is about double. the cost is about double for oil free. So people like oil flooded, but now I got oil to clean up. I got all kinds of problems. I have contamination of my product. The FDA and other stuff has rules on about incidental contact, whatever, on your food. It's just used in packaging or anything. It's not in contact with the food. It's just running the packaging machine. However, people like Costco, Walmart, Safeway, Kroger, are all requiring vendors to upgrade. And what they're saying is, if you're building something for us or making a product for us that I'm going to sell in my store, I take the hit for the reputation. If something comes out bad and they find out what's going on, sort of the Tylenol problem, it isn't the Nebraska meat company that gets out of it. They just change their name. They just call it whatever county they're in, meat company. And they just go on. But Costco is sitting there. They just got a big hit. We got to recall 1 million pounds of hamburger. Has that happened recently? It's usually E. coli, or something like that. But we don't want it for oil or any other contamination. So the retailers are driving the manufacturers to bring their standards up. And so we're seeing a lot more food and beverage using these more expensive machines to do that. So, does that make sense? I don't even know. Just something to go on. By the way, hospitals almost always have to use oil free or oil less. And so we used to have oil free piston machines with a distance piece and Teflon rings, and it was just a lot of maintenance on the valves and everything. Now we have screws that are in hospitals, like I said, university labs, biotech, biopharma. Oh, I forgot, high-tech. High-tech manufacturing. We're probably the biggest users of these guys in the Bay Area. We probably have 300 of these units in the Bay Area, San Francisco. That was our first biggest market. And of course, the Portland area with, what do we got, like 15 big fabs down there? The Intels and who else down there? We probably have, I don't know, another 300 there. I don't know how many you got up here, probably another 300 up here running around. Smaller ones, but yeah, they're around there. We have about 5,000 in the U.S. We have the entire U.S., actually we have all of North America with these.
Boeing's got a good number of the hospitals around here.
Have all gone to screws. Aerospace, good point.
Yep.
Yeah, you guys have aerospace.
Some places that require breathing air go that way.
Yeah. Breathing air, hospitals, medical, cannot have oil injected into it to meet specs, to meet requirements, and they would never risk, their entire business on that. So. What?
I said, well, some of them have done some
pretty
cheap.
gone cheap, or they're grandfathered in for right now.
Yeah.
So what about service? You guys get called out, you're on a routine, right? You go to your buildings on a regular schedule, or are you guys just like the fire department? We only call it, we only come if there's a fire.
We'll do everything.
Huh?
We'll do everything.
Yeah. Well, if you're like the fire inspector, you're trying to do stuff on a regular interval. I don't know how often you get to your customers, but this is what we do with rotary screws. The recips come in at this spot here. The monthly is just to test the oil on rotary screws. So I don't know if I took those out. Just to give you an idea of what we do on a daily basis. The customer has to do this. We don't see anybody on a daily basis. We don't see anybody on a daily basis. The oil level should be checked. All the filters, check their condition. Are the temperatures okay? Is the unloading valve set correctly? Watching it cycle if it's cycling. Do you see any leaks on the floor? That's my number one thing. I need somebody to stop for 5 minutes and see if there's a leak on the floor. If they catch that leak, we can avoid a machine, running to failure, that kind of stuff. So what happens is rotary screws are so, I'm going to say reliable. They go for decades. And people get in a pretty bad habit of just pushing the button and they're out down the hallway before the thing's even up to speed all the way. Sort of like checking the oil in your car. When was the last time you checked the oil in your car? You been to the gas station, did you check your oil? Anybody? Or did you just go to the 3,000 oil change and?
Don't they tell you these days?
Huh? Yeah. Yeah, I haven't. I'm about 2,000. No, I'm 3,000 into a 5,000 oil change cycle. I haven't checked the oil on that little POS Focus I drive just up and down I-5. But we need people to just stop and look at the machine for 5 minutes. Does it sound different? Does it whatever? And we're going to ask you for that. I really like the fact you guys had certain areas, certain buildings, certain zones. So you see the same systems over and over, right? So the good news is you should know when something is not right. The bad news is you might be too familiar with it, and you're so quick with it, you know, in that area. So, and we have them check. Hey, is it time to do anything? And fill in. We have a daily record card. Seth, I was supposed to send you one.
Oh,
Yeah, that's right. I'll send you. Or actually, Ryan, you live up here, so I can push this off on Ryan. He was hoping for a PDF copy of one of ours or something.
Okay.
They look like this. Pretty straightforward. I mean, you can put it in a spreadsheet or do whatever. I'm sure you guys have this for all of your equipment and buildings, or you just fill them out on your tablets. Just the day, what's the hour meter, air pressure, oil pressure, temperatures, oil level, who took it, and did I do anything? Yeah. So our guys do this. We have tablets now. You can fill those out, and they go right into our mainframe. Excuse me, our servers. That's really old school mainframe. Sorry.
They go through that computer.
Yeah, this is a mainframe.
Switchboard.
I just found a picture from about 1968 of the lady that programmed all the trajectories for NASA for the moonshot. And she's got printouts about this tall, and she punched each one of the cards. Those aren't the cards, that's just the printout. So there's about 60 or 70 lines per page going back and forth. There's probably 2 million punched cards there. Took her like 9 months. She wrote the code, had it punched, and I said, I did that. Not 4 feet of it, but it's.
For NASA.
Huh? And I didn't work for NASA either. So on a monthly basis, we ask our customers to just mail in the card. We'll review them for free for the life of the machine. And during the warranty period, you have to send it in. We want to know that you're taking the readings. Every 1,000 hours, we change the oil filter, we change the air filter, and we sample it if it's a synthetic. And we test the high temperature switches.
If it's belt drive, check your belt and shifts.
Good point. Good point. Most of yours are probably belt driven.
You send an oil sample off, or you guys are doing it as well?
Say again?
I said, are you guys doing the oil samples yourself, or are you sending them off?
No, they're just going off. They're in a little bottle, about $22 for the kit. And
Local?
No. It's our
Yeah.
oil manufacturer's lab. It's on.
2,000 hours. We perform the 1,000. If it's a old butterfly valve, you got to do it. If it's ATF, we have to change the oil every 2,000. But almost everybody is synthetic now, and the oil filters get changed every 1,000 hours.
If it's ATF on a belt drive, we do it every 1,000 hours.
Wow.
2,000 hours on direct drive.
Because they're running faster. Yeah. Are there any ATFs left? We've converted all of them in Portland. I don't.
We still have quite a few.
Yeah, they don't. We've campaigned them out.
It's an initiative we're working with.
Yeah.
Some customers are stubborn.
Yeah. The cost is the same. You can go about 4 times as long on synthetic, and it's about 4 times the price. You don't have the disposal, you don't have the labor to do all that work. So, this one is always an interesting one. Grease motor bearings, if applicable. Most people over-grease motor bearings. So, I don't know what you guys do on your pumps and your elevators and hydraulics and cooling towers or whatever you've got.
Usually until it starts spraying out.
You pump it with grease until it sprays out, or
Until the grease coats.
It's like a nice color power.
That way you can put them to chase the berries up.
when in doubt,
Good job, Joe.
yeah, when in doubt, don't. You're probably going to get more life if you just run it. They're sealed bearings. At any rate, when you get to the 8,000 hours on a rotary screw, we do the annual on it, or 8,000. We like to change the big separator elements in that big tank. We change the oil. We get all the lube out of it. And we look at the motor bearings again for some reason, you know. This is probably when you ought to call us. It gets the big over. You know, we spend, on a 100 horse machine, how long for an 8,000? Once you get on site and you're there, got all the parts.
A couple hours.
Okay.
2 to 3 hours.
Yeah, for our guys to do it. On the big guys, which you don't have, the big 1500s, we might send 2 guys and they spend half a day to a day on it. So.
Hey, they don't have them.
Here's what happens, guys. This is the risk of not doing this stuff. I got a couple poorer photos. Here's 2 rotors just like these, except a bearing failed and all the crap went through the screws for a long time. You know, and just ate it up. That, of course, never went back together.
Another thing to do on your services is blow out the coolers on the air cooler.
Yeah.
The cleaner you keep the coolers, the cooler the machine will run for you.
Okay. Air-cooled machines with those big radiators, that's that oil on there. Some of our guys actually take pressure washers with them, especially in the summer. Portland actually they watch the Weather Channel, and they know when it starts going up, especially on the east side, they got calls coming, you know, to do that. And they watch it when it dips in the fall, because they know they got dryer trouble. All the water is freezing up. They didn't maintain their dryer during the summer, and they get that kind of problem. So they'll see weather-related problems. Or I should say, the symptoms now become a problem, you know, so. The real reason this one wasn't, the bearings got so bad, the rotors ground into the suction plate and just ground it down probably an eighth of an inch. Even us can't, even we can't fix that problem. Huh?
She's just running a little loud today.
Yeah, you'll hear it. You'll hear it. And that's a good point. I like that, Mark. There's 3 symptoms you'll see before you want to call out. One is noise. You know, this guy is making a lot of noise. Those bearings have failed. And it isn't like we threw a rod through the side of the case. It's that the fact that the rotors slipped, and now they're getting tight. And so it's going to sound like 2 ball peen hammers going brrrr, you know, and I've pulled up outside of a compressor room and can hear it inside my truck, you know, even with Stairway to Heaven just finishing, you know. And I opened that one at Bohemia down in Grass Valley, California. They actually, the machine, the second one is vibration. You should be able to put a nickel on the top of the separator tank, and it should be able to sit there, you know, and stand up for a minute or so. And if it's level and it's good, a nickel will stand on it. But this one, they had put a come-along right across the air end to hold it down. They just put a come-along. Yeah. Wow. I don't have a picture of it. That mill has been long gone. And I just said, you need to change this air end, you know. The third one is you cut open the oil filter and you look for the little particles of bearing that are going to start doing this, you know. So generally I was going to say the 2 out of 3, when we get to 2 out of 3 of those, we'll generally call them out. But you should call us. This is a destructive teardown. If you send this in and we pull it apart, and nothing wrong, bearings are all good, everything looks good, no marks, no nothing, we can't put it back together without rebuilding it. There isn't just open it up and inspect it and put it back together, oh, it's good. We can't do that on site either. When you call it out, you pull it out, you put a rebuild in right then. And we rebuild this one back to our inventory. Except we didn't here, we just charged them for a whole rebuild errand outright, because they let it go so far. So we would ask you to call us if you think you've got noise and vibration, on the machine. Or if you want to, I don't know if you guys do that kind of work, cut open oil filters for inspection and that kind of stuff. Probably if you got vibration and you've got noise, call us. We'll come cut the oil filter out of it or open it up and look at it. Otherwise, your oil filter might look like that. Sometimes this guy did not maintain the inlet filter on this rotary screw. And remember I said the air gets washed by the oil? So the oil picks up that sawdust. And I keep talking about sawmills because that's where we started. In 49, 50, that's the only industry we really had were sawmills. And this guy let it go a long way. That's an amazing picture. Huh? You've seen something like this, right?
Peanut butter.
It's a peanut butter.
Yeah, it's peanut butter. Yeah, that's what it is. If you let the oil go too long, if you let the oil go too long, it breaks down these hydrocarbons and it oxidizes them. And it oxidizes them to varnish. And this is all black, but sometimes it's ATF used to go to that sort of caramel color. It looked like that stuff you'd dip apples in at Halloween. And it would be just about that consistency, and you'd have to scrape it. You basically had to disassemble the machine, scrape it out of everything. This of course, didn't go back together. So, here is a oil flooded air compressor with oil carryover in the condensate. And it's sort of a cream colored stuff. This is actually at a food processing plant in Bakersfield, California. Haagen-Dazs. At any rate, they're packaging with this air compressor. Now, we have, Rodgers has supplied them with some two-stage oil-free Cabelco units, and no longer, so I'm eating Haagen-Dazs again. For a while there, I didn't want to eat them. So, in addition to this condensate right here, it's full of oil. You can't just dump that in the drain. It ends up here in the sound, right? You got to treat it.
It's pretty big.
Huh? It's pretty big?
No, it's pretty big.
Yeah. Well, you got to run it through some sort of, do you guys have any oil water separation units that you got to do it, because you got to maintain those?
RSD.
Pardon? RS what?
RSD.
RSD. Oh, okay. What do we have? We have,
Oil water separator?
yeah. So, at any rate, these are great because you get to sell a lot of filters, a lot of activated charcoal and all kinds of other stuff. If you're coming out of an oil-free machine, you just run it to the drain. It's just water that came out of the atmosphere. So, common calls that we get. Let's finish this up, guys. Shuts down on high temperature. Rotary screws have a high temperature shutdown. Most recips don't. On it there. So, what do you think? How much you saw shut down on high temp? What do you want to look for?
Clogged oil cooler.
Clogged oil filter? You're not getting enough oil into it? You got a radiator problem like Sam?